All right, so we're going to go through number 4 on the back. The problem says Jael stands around tossing a tennis ball up and down while waiting for her parents to pick her up after school. Her hand is about 1 meter off the ground. Part A says if the ball leaves her hand going upward at 5 meters per second. So I'm going to say my initial velocity is 5 meters per second. This is my given. Writing my givens right now. How high above the ground will it get at its highest point? So we have the initial velocity, and again, I mentioned this yesterday, a problem that says it's thrown up at a certain speed, and it says how high will it go. You always have more information than it explicitly tells you. So what other information do we have? We have the acceleration due to gravity is going to be g, which is negative 9.8 meters per second squared. And we also have one other thing. What's the one other thing we have? Well, distance is what we're looking for. The final velocity. Remember, we want to know how high it's going. And so at the maximum height of anything you throw up in the air, at that maximum height, it stops for an instant, right? And so that final velocity will be 0. Good. So those are the 3 things we know. Our unknown now will be our displacements or technically distance, technically displacement. That's my question mark. Okay. And remember on the equation sheet, things look slightly different. Oh, never mind. Yeah, so where you see A's on the equation sheet, just substitute a G whenever you're dealing with free fall. And do I have an equation that has both velocities, the acceleration and the displacement? Both velocities, acceleration, displacement. That looks like kinematic equation number 3, right? The third one down. So that's going to be the equation I will pick. That is the acceleration is equal to the final velocity squared minus the initial velocity squared divided by 2 times the displacement. And we're trying to get the displacement by itself. So what I see here, the easiest way to do this would be, and remember, if it's in the denominator, I still see this, I'm still seeing this mistake. If what you're looking for is in the denominator, you got to get it out, right? You got to get it out. And so our next part, I'm going to go ahead and solve this first and then substitute in the values. If you'd rather substitute in the values in this step and then solve it afterwards, I'm fine with that. But I'm going to go ahead and multiply both sides by delta D in order to get it out of the denominator here. Okay. In which case I get delta D times the acceleration equals the final velocity squared minus the initial velocity squared divided by 2. Now some students have trouble, I actually don't like doing this. If I divide both sides by the acceleration here and I do this is gross to me. I don't really like compound fractions. If you know how to deal with compound fractions, that's fine. You just put the a over 1, multiply by the reciprocal, right? That's what you do when you divide by a fraction by a fraction. But another way of writing this, it means the exact same thing, and my brain likes it a little better, is I'm going to multiply both sides by 1 over a. It's the same thing as dividing, right? Dividing and multiplication are actually the same thing. When you divide, you're just multiplying by something in the denominator. And when I do that over here, it makes it a little more obvious that the a just goes in the denominator. Okay. And I still, on the left side, have numerator a, denominator a, leaving my displacement by itself, which is what we want. So I have the displacement delta D equals, the numerator, it's just final velocity minus initial velocity, all that times 1, which doesn't change it. And then I have 2 times a in the denominator. And there's my equation for displacement. Okay. Again, if you would rather start, once you pick your equation, by putting numbers in first, if you're more comfortable with that, by all means do it that way, especially on a test when the grades really do matter. And let's go ahead, I'll do the whole thing. Let's go ahead and do the whole thing. So delta D is going to be equal to final velocity, which is 0, minus the initial velocity, which is 5 squared. And we talked about this before. That minus doesn't get squared, so this doesn't become a positive. that minus is not in parentheses like this. You were subtracting the square of the initial velocity. So we're subtracting the square of 5, or subtracting 25, obviously. And that gets divided by 2 times the negative 9.8 meter per second squared acceleration. And then I'm just going to do this slowly but surely. 0 minus 5 squared is negative 25. Divided by 2 times negative 9.8 is negative 19.6, I think. Okay, thank you. And then, oh, you got a calculator. Sweet. So what happens when you do that?
Positive 1.27.
1.2.
Yeah, because you have to round it.
Okay. Oh, 2.6?
2.8.
2.8. Gotcha. So 1.28 meters. Notice if you had had a negative here, then you would get a displacement of negative 1.28 meters. And when you throw something up in the air at the maximum height, it's not going to be below where you threw it. So hopefully, if you got that negative as your answer, if you're thinking critically about it, you'd realize it doesn't make sense. Okay. So that's the answer to part A. I now have the displacement. Okay, so part B now. Starting here, I'm probably going to have to do some erasing here. Part B says if she misses the catch on the way down, how long will the ball... this... I got it wrong. Look at the underlined words. It says how high above the ground will it be? Her hand is about 1 meter off the ground when she threw it. So what should the actual answer be? Yeah, so the actual height above the ground, I totally did that on purpose, is 2.28 meters. So be careful there. That is the actual answer. The displacement, when we calculate displacement, it's displacement from the starting position, which was that original 1 meter off the ground. But since we want to know the height, since the question says how high off the ground is it, then we got to add that additional 1 meter to it. Sorry. Oh, sorry. All right, so I'm going to go ahead and start B over here. Can I erase this? This will be a video that you'll be able to access on the module, so if you need to watch it again, it'll be there. Okay, so if she misses the catch on the way down, how long will the ball be in the air from the time it leaves her hand to when it hits the ground? I'm going to go over the hard way first, and then tell you how you would do it if you didn't want to do it the hard way, and that's fine. But I'm going to go ahead and do it the hard way. I'm going to draw a diagram real quick. So here, it starts here, it goes up, and then ends up falling to here, right? And you'll see why it's a little harder when we do it this way. We know that the initial velocity was 5 meters per second. We know the acceleration is the acceleration due to gravity. It's negative 9.8 meters per second squared. We don't know the final velocity now, right? Final velocity is not 0 now. So that's not really going to help. But we do know the displacement. Or at least we can determine the displacement from the problem. Can anyone tell me what the displacement is? What's that? I can't even hear you. I'm old, my ears don't work.
Is it 0.28?
It's not the point that and this is what's weird. If it starts from here and it ends here, and it's just straight up and down, but I can't draw like that. If it starts here and ends here, the displacement is just from the initial position. So if I was to draw that as a vector, it would be from where it starts to where it ends. That's my displacement vector.
So, 1 meter?
Almost.
Negative 1?
-1 meter. Because it's downward, right? It starts at 1 meter, ends at 0. And so if I was doing my deltas as like this, delta D is final distance minus initial distance. Well, my final distance is 0, ground level, minus my initial distance, which was 1, which is -1. That's the mathematical way of looking at that, but you can just say if it's a vector that points down, then it's negative. Okay. So my delta D here is actually negative 1 meter. So that's something we didn't have in the last part. We actually had to calculate the delta D in the last part. But here we have something different. And then, what are we looking for? We're looking for how long is it in the air. And the only equation that we can use to solve this is the fourth one, the last one. The last kinematic equation. Sorry, this is my givens. Here's my unknown. Now the equation. My equation is going to be the displacement is equal to the initial velocity times the time interval. Sorry, that's delta t. Plus 1/2 times the acceleration, which is g, times the time interval squared. If t is our unknown here, can anyone that's good in math, either in Algebra 2 or pre-cal at the moment, if t is our unknown here, what kind of an equation are we going to have to solve? Starts with a Q. This is a quadratic, right? So when you have to solve a quadratic, this is one case where I would say definitely plug in the numbers. Plug in the numbers first, because you don't want to have to deal with putting this, because you're going to have your A, your B, and your C, right? And you don't want to have to deal with that in addition to the quadratic formula. Don't use the quadratic formula. Know how to use it, but I'm fine with y'all using your calculators to do it, because I can't remember the last time I solved a quadratic equation using the quadratic formula. That's what your math classes are for. So what I'm going to do, I'm going to go ahead and plug in the numbers. So delta D is -1. My initial velocity is 5 times delta T plus 1/2 times -9.8 times delta T squared. And I'm going to actually do this multiplication here before I do anything else. So I have -1 equals 5 delta T. And then positive 1/2 times -9.8 is -4.9 delta T squared. So in your math class, you probably have at this point. I mean, you should have. Isn't that Algebra 1 when you start doing quadratics? Yeah. So this problem in your math class might be -1 equals 5x minus 4.9x squared. Solve that for x. Right? So if you ever come across this, and I'll tell you how you can go about solving this problem without doing the quadratic. That's okay if you want to do it that way. But what do you have to do first when you solve a quadratic? What has to be on one side of the equal sign? Zero. You got to put a 0. Or you got to get 0 on one side. And then you write in descending order, right? Where you have the x squared term, and then the x term, and then the constant term. In this case, it'll be the delta t squared term, the delta t term, and then the constant term. So I'm going to go ahead and add 1 to both sides, because that'll put a 0 on the left side. And then I'm going to write it in descending order. So I have 0 equals -4.9 delta t squared plus 5 delta t plus 1. Right, we added that one to that side. And again, if you want to do this like you do in your math class, just replace the delta t with an x. So it'd be -4.9x squared plus 5x plus 1. And then if you want to use the quadratic formula, x equals -b plus or minus the square root. Did you guys learn the song when you learned that? Square root of b squared minus 4ac all over t. But you got to do that twice, right? You got to do that twice. And anytime you have a physics problem like this, a kinematics problem where you have to use a quadratic formula, there's 2 answers. One of them doesn't make sense. One of them will give you a negative time value. So that's like saying I throw it up in the air and then it hits the ground. How long is it in the air? -3 seconds. It doesn't make sense, right? So one of those answers will be extraneous. The other one will obviously be positive, and that'll be the right answer. But especially since y'all will have access to your computers when doing all this stuff all year long, the easiest thing to do, unless you just use your calculator, because those fancy calculators make solving quadratics really easy too. The one that I like to do, it's the First one that pops up, if you just type quadratic solver, first one that pops up, math is fun. You put in your A, you put in your B, you put in your C, and it just spits out the answer. And so our A, sorry about that, is negative 4.9. Negative 4.9. Our B is 5. Sorry, 5, that's nice. And then our constant term C is 1. And then it automatically determines the answers.
You put negative 4.8 instead of negative
Oh,
4.9.
thank you, thank you. You passed for the day. Okay. And so notice I have two roots, right? When you're solving a quadratic, you're solving for the roots. And for us, those are the times at which the object is at the ground level, at the horizontal level. One of the answers, negative 0.17 seconds. Well, that doesn't make sense, right? So it's 1.19 seconds. So if you throw an object up from 1 meter high, and then you miss it on the way down, and it hits the ground, then it'll be, and you throw it up at 5 meters per second, it'll be in the air for 1.19 seconds. That's just math, right? This is a physics class. We use math, but I'm not gonna say you have to use a quadratic formula. You have to get 2 solutions and then pick the right one. You can use technology to solve the equations if you want. Okay, I'm fine with that. I want you to focus on the physics. The physics is representing the motion with these equations, right? And then solving those equations for a physical variable that actually represents something in reality. And then when you come across something like this where you got a quadratic and you're like, I don't want to solve a quadratic. Use your calculator, use your computer, use your phone, whatever you want to do. Okay. All right, so how would you solve this problem if you didn't want to use the quadratic formula? Well, we just use our initial stuff, or what we found out at first. We found that delta D, or the height, I'm sorry. We found that the height above the ground was it 2.3, what was it? 2.28 meters. We know it's going to end up at ground level. So we can just solve, that's why the problem A was done first, or problem part A was done first, because you figure out exactly how high it is at that point. And then you can do part B as a totally separate problem. Just solve it again with that initial condition, when it's at the top at the end of part A. So at the end of part A, our final velocity was 0, but that's now going to be our initial velocity for when it's coming back down, right? And so when it's coming back down, you get the initial velocity will be 0. What else do we know? We know the acceleration due to gravity, negative 9.8 meters per second squared. These are my givens now for part B. That's G. Then we know the displacement. What's the displacement going to be? Be careful. Negative 2.28, right? Negative 2.28 meters. And then we need to find the time that it takes to do that. The problem here is that, oh yeah, we calculated the, no, in part A we didn't calculate the time, right? Yeah. So that's why I would actually use the quadratic, because now I have to solve for the time from part A, the time it takes to get to the top, and then the time it takes to get to the bottom. So I'm going to have to do part A again to find the time, and then I'll have to do part B to find the time that it takes to come back down, and then add those times together. Right? Because here I got an equation. Which equation goes with these? Is the second one again. Right? Delta D is the initial velocity times time plus 1/2 the acceleration due to gravity times the time squared. And note that we won't have to do a quadratic here to find delta t, because that middle term, my initial velocity is 0, that middle term is now 0. And so it's easier to calculate the time interval now. I can solve this for delta t just by square rooting both sides in the end, right? But again, I will have to go back to part A and determine the time that it takes to get to the top using the variables from part A. So it's more work, but it's less algebraically difficult to do it that way if you just split it into 2 different problems. But then if you like the quadratics, you can do that as well. Okay? Any questions about that? All right. So go ahead and use the rest of the period. You got about 15, 16 minutes. to keep working on that. That is homework, so Ms. Coons did get you started with the front side, so it shouldn't take you too long to get that front side done. I helped you with number 4. Number 5 is a similar problem to number 4. And you probably reach an interesting conclusion on number 5 there. But yeah, that's it. Let me stop the video.